Yeah. Hello guys. In this tutorial, I'm going to teach you the problem flatten binary tree into linked list. It means they'll give us a binary tree. We need to convert it into a linked list. So let's read what they actually gave in the question description on the platform leetcode. So if you want the question that I'm teaching on lead code, you can search question number in the field, enter question number or title. You can search 114 or you can type Latin binary tree to linked list. So let's see what they actually gave us to do. Given a root of a binary tree, flatten the tree into a linked list. So usually what I told, they also told the same thing that so they just give the root of the binary tree. It means they will give you the tree binary tree. You need to convert it into a linked list and return them. So the linked list should use the same tree node class where the right child pointer points to the next node in the list and left child pointer is always null. So the order should not change. I mean, you should always point your right pointer to the right child, but the left is always going to be the null because you are at the you're actually doing the linked list. You're converting into linked list, right? So there's no such kind of left pointer here. So the linked list should be in the same order as a pre-order traversal of the binary. So assume that this is a given tree and don't bother about this one. This is actually the output, and the pre-order is nothing but 1 2 3 4 5 6. That is a pre-order. So the output linked list order should be same as what I told now. One, the same thing is there. You can see 1 2 3 4 5 6. So this should be maintained in the output. So let's discuss the approach, and I have set up everything. Yeah. So they told that you always should make your left pointer equals to null and the right pointer always points to its child nodes that they have mentioned. So you can say that in terms of code, you can say that if node dot means your your root dot left equals to null, and what are things you need to figure. Your root dot right is always going to be the node the current. So usually initially we will have a node type of list node. Sorry, it's not list node, it's actually tree node. Yeah, what they have mentioned in the as per the question, we can use the data type. So for now it's just a pointer of named previous, initially pointing to the null. So previous equals to null. So this is the node that initially we actually declare it, and when we are traversing, we actually do traverse from the right subtree. That means usually in pre-order traversal, what you will do, left root, sorry, in pre-order, first you will do the right root part, then left and then right. But for this question, the approach is we need to go completely reverse against the pre-order. It means for pre-order, as I told you that we need to go from right, left, sorry, for pre-order we need to go root, left, right. So when I'm saying opposite of the pre-order, then what is the order? The order is right, left, root. So right means 6 and you will go this way. It means the whole traversal is we are doing this way. Okay, you do understand my point, right? So at every time after you process this node, you will assign the previous pointer to here. Initially it was null somewhere around there. Here assume that usually previous pointer is at here and null is pointing towards this one. It means this node is actually pointing towards this one. So next in the next step, this is going to the previous, and when we are at 5, we point our previous to the 6 and make the previous here, and this is a whole logic, and we'll traverse this way but not one, and we'll come this way, and when we actually hit null, then we'll actually do the same thing. So first we will go root dot right, then we'll go root dot left. I'll directly show you in the code, that would be more simple for you. Yeah, where's my code? Yeah, how can I get this one? Yeah, this is what am I talking, and I want to be this one. Yeah, okay. So you can see this one, right? So usually what I'm saying is, first you will do the recursive stuff. When this is equals to, you will just return it's a void type and flatten root dot right. Yeah, as I told you, we'll go from the right and then left, and then when we return this one, we complete this part red line, then we'll come below and root dot right equals to previous. It means usually previous is actually pointing to null, so I'm just saying n. So root dot right, so currently at this point root dot right is nothing but we are pointing at, we are sitting at 6, and 6 dot right is actually null. So our root is 6 and 6 dot right equals to null, and we pointed to, we made a connection to here, and this is the previous pointer, and we finally change our previous pointer, this one, to here. So a pointer is currently previous, which is pointing towards 6, and no longer our previous is pointing to null because we are being changed in the last line. If you see the in the code, see here, previous equals to root. So actually this is root, so we are making it to previous. So root and previous are this one, and we're ending this block, and we'll go up where we actually got left, and for we left at this part, node 5, and this line is actually completed because this actually returned as the value, and we need to go for that root dot left, and root dot left actually gives us null, and root value is equals to null. Yes, that's true. So this returns nothing, so we'll complete this line, and then here root dot right equals to previous. So currently our root is actually 5, right? So 5 equals to previous, it means previous is nothing but 6, so we point our 5 to 6. That's it. So next, root dot left equals null. So as I mentioned, root dot left equals null for every node. We'll just point this to null. I forgot to add this one also. For this one also, it is actually being null only. For every single fucking node, you're gonna point its left pointer to the null. That's what you can do. So then next, move your previous pointer to the current root, which is 5. So this is going to be the preview. I think I actually need to move my image somewhere else because yeah, let's move this. Yo, I want my image here. Yeah, do we actually need this stuff? Yeah, let's remove this one. Holy shit. Both. Okay. So currently this is our linked list, and the hell. So let me, I guess I need to remove this one or what? No problem, I guess. Yeah. So currently this is pointing to the null, and okay. And this is root dot left is equals to null, and this is previous, and there is, and for the next iteration we are actually at, we'll do root dot, we completed root dot right for this line. So 5 is coming from this one, and we completed root dot right, which is this line we have completed, and we need to go for root dot left. So our root is 1 for now, and we'll go root dot left, which is 2, and then we'll come from top and we'll do root dot right. So 2 dot right equals to 4. So here we'll again call root dot right, and we'll come from top, sorry, not from top, here I need to show that. And we are again doing, we are actually pointing to the null now. Then root dot root value equals null, yeah, that's true, so return there. So we are at root node 4, and what we are doing, root dot left, we are doing root dot left now. And this will also makes returns nothing, and we are sitting at the node 4, and we'll do root dot right equals to previous. So 4 dot next actually equals to previous. What is previous? Previous equals to 4. So root is 4, and 4 dot next equals to previous. And we had made the connection, and 4 dot left equals to, it means root dot left equals to null, and we are pointing a pointer to the null, and we need to move a pointer previous to the 4, which is the current root. And we have done that thing, and we'll close the braces. Here it's actually not visible for you, but let me try, guys. I need to get right. What the heck? Yeah, wait a moment, I'll make sure this one, yes, perfect. So we got current pointer to be 4, and then what's the next step? And we are closing the bracket. It means we actually completed that line. What line? How we know that line? Because this one is right? So we completed this part, and we added to the linked list, and we are at node 2, and the right is actually completed, this line is completed, and we need to do this part, root dot left. So 2 dot left is actually 3. So our current root is actually 3, and which is not equals to null, and we'll do root dot right again here, and it will give, we point to null and returns nothing, and we are at 3, and we'll call root dot left, and it will also return nothing but 3. Not, it won't return anything, we'll just be at 3. And 2 lines are completed for this one, and the next one is root dot right equals to previous. So currently root is actually 3. 3 dot next equals to previous is pointing towards, sorry, yes, previous is pointing towards 3, and it is being connected, and root dot left equals to null, and previous equals to root. So this way, if you observe that, we are actually preserving the order. uh, how can I do this now? Wait a moment. Yeah, perfect. I think I need to draw smaller. Yeah, currently we completed this part, this node, and which means we completed left for this node. It means both are completed for this node, and we'll go back to here, sorry, we'll go back to, we'll both completed these two lines, right? So we are at here, and what we need to do is root dot right. Currently we are at 2, so our root node is actually 2. So 2 dot right is actually previous. So we are point, this is previous, I haven't tried that, you do understand one, right? So root dot right equals to previous, and root dot left equals to null, and root equals to previous. So our current root is actually going to be the previous, and we done that, and the stuff is done, and this one also completed. So we'll return back, and left is completed means we are at this line, and our current root is actually 1. And if you see what is the root dot right, so root dot right equals to previous, will connect to this one previous, and root dot left equals to null. And what's the final line that we need to do? Previous equals to root. So our current previous pointer is pointing to the head of the linked list, and this is a final linked list which is being converted from binary to linked list. If you see the order, 1 2 I need to draw cycles because these are nodes, right? To be represented as nodes, I need to draw the cycles, which makes them the real nodes. Yeah, if you see the order, it actually presents 1, 2, 3, 4, 5, 6. Yeah, that's what we want. I'll show you in the diagram. Yeah, here. If you see this diagram, yeah, how can I show you? Yeah, if you see this diagram, 1, 2, 3, 4. Yeah, that's what we got. 1, 2, 3, 4, 5, 6, and 6. Then will point to the null. That doesn't matter here because we'll definitely point to the null. Yeah, that's it for the question. Thank you.